The James Webb Space Telescope has just sent Earth a tremendous rebuke, and it's moving closer. This cautioning comes from the exoplanet Proxima B. With each new picture sent back, extra requests arise, leaving experts frightened. Each study from this distant planet makes us wonder more about the mysteries of the universe, creating questions about an expected threatening planet near Earth. Could there be an adjoining outcast planet that has disagreeable intentions? Could Proxima B, of all places, address a threat to our actual presence? The subject of extraterrestrial life has dazzled humanity for many years. However, with current innovations like the James Webb Space Telescope, it has become an inquiry we can investigate more thoroughly than ever before. Yet the universe isn't making it easy to track down answers. We continue to use our best tools, such as the James Webb Telescope, to get brief looks at distant planets and worlds, hoping to find bits of proof that might demonstrate life beyond Earth. We must be hopeful, but every new picture and snippet of data usually reminds us of how little we really know. While these revelations could be memorable, they also highlight the endlessness and multifaceted design of the universe, leaving us with additional inquiries than answers. Grasping a far-off planet like Proxima B could reclassify our place in the universe. For scientists in space science, this is exciting, but for the general population, it frequently feels like just one more piece of space news, distant, dynamic, and sometimes overwhelming. These discoveries raise more questions than they answer, driving many to consider how this affects life on Earth. Could Proxima B really harbor life or even intelligent life that might one day present a danger to us? Notwithstanding the epic force of the James Webb Space Telescope, it can unfortunately show us only a limited amount. Sure, we've learned some unimaginable things, like the fact that we now have stunning new pictures of Proxima B, and that the universe is altogether larger than we ever imagined. But what comes next? The viable implications of these revelations can feel as big as the universe itself. Proxima B, discovered in 2013 due to its gravitational cooperation with its star, was a significant scientific breakthrough for many specialists. Finding this exoplanet was like finding a new celestial neighbor. Proxima B is just somewhat bigger than Earth, and it orbits its star every 11.2 days, making it an interesting subject for further examination from a scientific perspective. The possibility of a distant universe so close to our own is invigorating. Yet for most, it's hard to connect with a place that is 25 light-years away. To put that into perspective, even the fastest rocket humans have made would require many centuries to reach it. Imagine what it might be like to stand on Proxima B. Its star, Proxima Centauri, would appear as a faint red light overhead, much cooler and darker than our Sun. Proxima B orbits so quickly that a year there lasts a bit over 7 days. One side of the planet constantly faces the star, meaning it's locked in eternal light, while the opposite side is shrouded in timeless night. It sounds like something out of a sci-fi novel, but the reality would be much more extreme. On the bright side of Proxima B, any water would undoubtedly boil into steam due to constant exposure to heat. On the dark side, however, the water would freeze into solid ice. The planet's star, Proxima Centauri, is also not a peaceful and consistent neighbor like our Sun. It throws out dangerous flares and intense radiation, causing the surface of Proxima B to be a hazardous spot for life as we know it. This isn't the sort of area where people would want to settle. Interest in finding life beyond Earth peaked in late 2020 when researchers detected a strange signal coming from the Alpha Centauri system, where Proxima Centauri is located. This signal had an unusual frequency of 982.551 MHz, which grabbed everyone's attention. Such a signal could theoretically be a sign of advanced technology, but it's too early to make any conclusions. More recently, the James Webb Space Telescope sparked even greater excitement by suggesting that Proxima B could have water vapor in its atmosphere. Water, as we know, is a crucial element for life, and its presence could be a game-changer. To better understand how much water is present on Proxima B, analysts are using advanced techniques like spectroscopy. This method allows them to detect the gases surrounding the planet, behaving like a cutting-edge investigative tool. By studying the planet's light spectrum, researchers can identify specific gases like oxygen, methane, and carbon dioxide, all of which are essential for life. Environmental modeling is another important strategy. By using automated simulations of Proxima B's climate, scientists can make reasonable conclusions about its conditions. These models serve a similar purpose to how researchers use dinosaur fossils to recreate what dinosaurs might have looked like. However, the more we learn about Proxima B's environment, the more we are reminded of the astounding diversity of life forms that exist here on Earth. Extremophiles, for instance, are tiny creatures that can survive in extreme conditions such as extremely hot springs, acidic lakes, and the freezing cold of Antarctica. These tough animals show that life can adapt and thrive under conditions once thought impossible. Could life on Proxima B be just as resilient? The search for life on Proxima B presents enormous challenges, not just in terms of space travel, but also in proving that life could exist in such a hostile environment. The planet is bombarded by intense space radiation, and its atmosphere may not offer much protection. Furthermore, the distances involved are so vast that new propulsion systems are required to make space travel to Proxima B feasible. Concepts like solar sails, particle propulsion, and even more theoretical ideas like warp drives offer exciting possibilities for future exploration. However, these technologies are still in their early stages and require extensive research before they can be used in real missions. While dreaming about future space travel is exhilarating, we need to stay realistic. Finding life on Proxima B is filled with technological and scientific obstacles. Only by advancing our technology and expanding our understanding of the universe can we hope to unlock the full potential of distant worlds like Proxima B. This journey is not just about satisfying curiosity. It's about pushing the boundaries of human achievement. Might we one day step foot on Proxima B or even contact life there? As we consider the long journey to Proxima B, finding aliens no longer feels bound to the realm of science fiction but instead appears like a genuine, tangible possibility. This astonishing shift from a distant dream to a scientific endeavor has drawn considerable attention from cutting-edge organizations like Breakthrough Initiatives. These groups are dedicating significant resources to turning what would normally be an unfathomably long journey, one that could take millennia, into a mission that could be completed in decades. The goal of reaching another star system within a human lifetime has begun gaining momentum and confidence within established scientific circles. However, these grand ambitions are quickly tempered by the stark realities of our current technological limitations. Notwithstanding significant advances in space exploration, traveling to Proxima Centauri, indeed even at just 4.2 light-years away, still presents daunting challenges. Current propulsion systems are simply not fast or efficient enough to make such a journey possible within a reasonable time frame. The Breakthrough Starshot, one of the most ambitious projects, imagines using powerful laser-driven sails to propel small spacecraft to speeds of up to 20% of the speed of light. While this idea shows promise, it is still in the experimental stage and requires overcoming several technical and logistical hurdles, such as protecting against space debris and ensuring reliable long-distance communication. While the dream of reaching Proxima Centauri and potentially finding alien life is closer to reality than ever before, it is still grounded by the limitations of current technology. Accelerating a spacecraft to near-light speeds with today's tools feels exceedingly difficult, like trying to solve a complex puzzle in the dark. Even ambitious projects like Starshot, which aims to send a spacecraft toward Alpha Centauri using lasers, face significant practical challenges. The Earth's atmosphere causes disturbances for the lasers, making it challenging for space-based instruments to work with the precision required. One proposed solution is the use of adaptive optics, smaller lasers on satellites that constantly monitor and adjust to atmospheric disturbances. This system would help powerful ground-based lasers stay on track as spacecraft travel through space. However, the laser propulsion method requires an enormous amount of energy, equivalent to the total energy consumed by the entire US in a year, and would only work for a limited time. Imagine setting up 100 million lasers over a vast area just to propel a small spacecraft, only 33 feet wide, to 20% of the speed of light. At this speed, the spacecraft would still require 22 years to reach the Alpha Centauri system, a time frame longer than many people's lifetimes. But the challenge of reaching Alpha Centauri is not just about surviving technical obstacles. There are natural barriers as well, such as the sun's gravity, the presence of space debris, and the sheer enormity of the distance involved. All of these present significant risks. Even communicating with a spacecraft en route to Proxima B would require sending messages through time. It would take nearly 4 years for a message to travel from Earth to reach it. Notwithstanding these complex challenges, the desire to explore other star systems continues to grow. It is driven by humanity's deep love for discovery and exploration rather than practical need. Even ambitious ventures like Starshot, which intends to send a spacecraft to Alpha Centauri using lasers, face many practical challenges. However, solving these problems could revolutionize space exploration. Still, the potential dangers involved, including communication delays and natural hazards, require careful planning. All things considered, many scientists believe the rewards far outweigh the risks. Finding life elsewhere in the universe, especially on a planet like Proxima B, is worth pursuing. Although the difficulties may seem insurmountable at times, the search for knowledge and the future of humanity in space remain incredibly bright. In the future, the question will not just be whether we can reach Proxima B or other distant stars, but how soon we will overcome these challenges and make new discoveries that will redefine humanity's place in the cosmos. As the search for life beyond Earth intensifies, Proxima B continues to captivate the imagination of scientists and the public alike. The possibility that it could harbor life or even intelligent life raises profound questions about our place in the universe. While researchers explore the potential for such life, the challenges of confirming its existence are monumental. The harsh conditions on Proxima B make it an unlikely candidate for life as we know it. Yet it also serves as a reminder of how adaptable life on Earth can be. Understanding the extremophiles that thrive in Earth's most hostile environments gives us hope that perhaps life elsewhere could also find ways to survive in seemingly inhospitable settings. In recent years, space telescopes like James Webb have dramatically improved our ability to study distant worlds like Proxima B. These cutting-edge instruments provide a window into the atmospheres of exoplanets, revealing complex details about their composition and structure. By examining the chemical signatures of these distant worlds, astronomers can infer whether conditions exist that could support life. These observations, while limited in scope, are a critical part of the growing body of knowledge about planets outside our solar system. They offer a glimpse of the vast, uncharted territories that might one day hold the key to answering the age-old question: are we alone in the universe? The study of Proxima B also highlights the importance of collaboration between scientific disciplines. Astronomy, physics, biology, and even philosophy all intersect in the search for extraterrestrial life. While astronomers probe distant stars and planets, biologists study how life could survive in extreme environments, and physicists work on developing new technologies that could one day allow us to travel to these distant worlds. The pursuit of knowledge about Proxima B and other exoplanets demands an interdisciplinary approach, uniting researchers across the globe to solve one of humanity's most profound mysteries. A key aspect of the search for life beyond Earth involves the concept of the habitable zone. Proxima B resides in the habitable zone of its star, meaning it's at a distance where liquid water could potentially exist on its surface. However, being in the habitable zone is not a guarantee that a planet can support life. A host of other factors, such as a planet's atmosphere, magnetic field, and the stability of its orbit, must be considered. Proxima B, for example, may be subject to intense radiation from its star, which could strip away its atmosphere and make it less hospitable to life. These environmental factors are complex and require further study to understand the full picture of what makes a planet truly habitable. The presence of water vapor in Proxima B's atmosphere is one of the most exciting findings. Water is often considered the key ingredient for life, and its discovery on a distant exoplanet is a promising sign that we may one day find evidence of extraterrestrial life. But the mere presence of water does not guarantee that life exists. The conditions on Proxima B could be so extreme that even with water, it would be impossible for life to develop. This underscores the challenges scientists face when looking for life beyond Earth. The search is as much about eliminating impossibilities as it is about finding evidence of life beyond. The study of Proxima B also has implications for humanity's future. If we ever hope to reach other star systems, the lessons learned from Proxima B will be invaluable. Technologies developed to study exoplanets could one day be used in missions to explore these worlds directly. Concepts like interstellar probes, advanced propulsion systems, and autonomous spacecraft could open up new frontiers in space exploration. However, the vast distances involved present a significant hurdle. The idea of sending a probe to Proxima B or other nearby stars remains a far-off dream, but with each new breakthrough in technology, this dream edges closer to reality. The dream of reaching other star systems also prompts a reflection on humanity's future on Earth. As we look to the stars, we are reminded of the fragility of life on our own planet. Environmental degradation, climate change, and geopolitical tensions all present challenges to our way of life. The pursuit of space exploration, particularly the search for life beyond Earth, is a reminder that humanity's future is not guaranteed. Our survival may depend on our ability to explore and adapt to new environments, both on Earth and beyond. As the James Webb Space Telescope and other scientific instruments continue to provide new data, our understanding of distant worlds like Proxima B will evolve with each discovery. The possibilities of what we might find in the universe expand. While Proxima B remains a distant, mysterious world, its study offers valuable insights into the broader search for life in the cosmos. It also serves as a reminder of how much we have yet to learn about the universe and our place within it. The search for life on Proxima B and other exoplanets is not just about the science. It's about pushing the boundaries of human curiosity and exploring the vast unknown that stretches beyond our planet.